So we are doing with the ASA fire overview, and also we are going to study your ASA firewall initialization stuff. That's the topic for today. So what we do is right now we go to our lab topology. So what we have here, I've taken one ASA that is connected to outside. We have got a couple of interface facing DMZ, one interface facing your inside, and you can see the bold ones, the much security level that I have kept. So I've got here, a couple of DMZ and one outside, one inside. So 100 for the inside, 0 for the outside, 50 for the DMZ. Everywhere I'm using the private networks for DMZ and the inside, but only on the outside interface I'm using a public network. And these are the outside networks that I want to reach. Say 10.2, 199, 200, 10.4, some resources on the DMZ, 10.3. Likewise on inside I've got some corp resources of 10.20 and 10.1s. All right. So what you do is, you set up the same topology like this, okay? Whether you work with packet tracer for ASA or whether you work with GNS3 or EVNG. Great. So initially what I do is I will show this from the scratch, how do I configure it, so you can have a good idea. Generally, on the iOS, router iOS is a good command line console 0, logging synchronous, executable timeout 00, no IP domain lookup, right? These are the basic best practices commands that you normally type. So I'm going to R1 and configuring the respective IPs. All right, so what I'm doing is I'm configuring here a couple of loopbacks. So first loopback is 10.1.1.1 as per my topology is considered. The second loopback is say 10.10.10.1. And I have got an interface say 0/1 that is having an IP address of 10.20.20.1. All right, and also E0/0. This interface is going towards a firewall that is 10.11.11.1. And hostname say it is R1. Done with this, let's go to R2, which is the outside router. We'll have 3 loopbacks. First loopback is configured as 10.2.2.1. The second loopback is 199.1.1.1. The third loopback, it is 200.1.1.1. And the interface, which is E00 of the router, I'm treating this as an internet or ISP router for me. This is having 192.1.20.2 as the public IP. That's it. Going back to R3, it needs a couple of IPs, one in the loopback and one in the interface. All right, and on E00, 192.168.3.3. That's all. Last router here is R4. There's a couple of IPs, one in the loopback as 10.444. The E00 interface, this is going to 192.168.4.4. Right, that's all. And now what we do is on the ASA, So my, all the routers behind the ASA, surrounding the ASA is configured with the respective IPs. Now on the ASA, first thing first. So when you go to the ASA, once the ASA is initialized, same stuff, enable, and by default, it prompts you a password, but it does not have any password there by default. So just say enter without any password. So now once you go to the privilege mode of the ASA, if you type the command show, so normally you have the habit of typing show IP interface brief to check the interface status and the interface IP address is configured, right? But in case of ASA, the command is a little different. It does not show IP interface brief, it is show interface IP brief. Okay, show interface IP brief. And then you can see how many interface right now this firewall is having. So you can see that we have got one management interface, and we are keeping the rest of them as the gigabit Ethernet interface, right? So they support all 1 gig ports. So I've got 6 ports over here. And if you see show version, we are talking about 9.5 here, the latest version of ASA. All right. And if you talk about the services that is connected and the features, you can see which all features are enabled and which all services are there by default. Then show version command itself. So now when you go to the global config mode, there's a very interesting fact is you can use the show command from here as well. But on the routers, generally, you will be using a keyword called as do before the show commands, right? So like do show something. So here you can execute the show commands directly. So show interface IP brief from the global config mode, it gives you the same output. Likewise, show route will show the routing table. As of now, there is no route that is configured here. Okay. So most of the commands you will see that the IP keyword is not required with ASA. For example, show IP route was a command that we type on the routers, right? But in case of ASA, this command is not required with IP keyword. So normally if you type show route, that's enough. Okay, because ASA supports only IP as addressing protocol. It does not support IPX, talk. There is a reason, the IP keyword is gone. So they don't use IP keyword for any or most of the commands. All right. So now, for example, if you see show run interface, there is a good command, show run interface. You can see that these interfaces are having what configuration right now. So by default, it's a blank ASA, and with a blank configuration on the ports, nothing is configured. And if you want to configure something, you have to go to the interface level. So let me look into my topology and let's see, what I have here. So I have to go to interface G00, right? So interface G00. I have to give no shut, activate the port, give an IP address, which is 10.11.11.10. So on ASA, on all the interface, I'm keeping the host IP as .10. Okay. And since it is classless IP, so I have to give the subnet mask. And along with that, I have to give, the nameif command. So nameif, I want to keep this as inside. So it is not case sensitive. If the characters are inside with INSIDE, I told you that automatically the ASA will put, a security level called as 100. So you can see that the security level is set to 100 by default. Okay. So if I wanted that this interface should have a security level of 100, that means it is not required that I go with this command. So security level, I told you the range is from 0 to 100. So it is not required here that I give this value, because by default it is taken as 100. Okay, if I want, I can do that, but it is not required over here. Okay, so that's it. Similarly, going back to the other ports, which is say G01, it is going to your DMZ, say 4 and 3 respectively, I've named it. So G01, no shut, the IP ad is 192.168.4.10. And since it's a classful IP, I want to keep the mask as this. So this will become a classful. And if I give a classful IP address, which will have the default mask, for that, it's not required that I give the mask. Okay, I can just type the IP address and hit enter. And here, nameif is your DMZ4 as per the topology. And I told you any name you give apart from inside, security level will be 0 by default. So what we do is you keep a command called as security level and you give a value. Say I want to keep the value as 50, so I give 50 over here. Coming back to the other ports, so G0/3, no shut. This IP address is 192.168.3.10. Again, it's classful, so just hit enter. Nameif, so it is DMZ-3. Security level is 0 by default, we know that, but I want to keep it as 50. So I'm keeping this as 50. And last but not the least, interface G02 that is going towards your outside should have generally a public IP. So I'm giving 192.1.20.10. Again, classful. So I'm hitting without mask, and name if is outside. Security level is 0 by default. No need to configure security level separately with a command because I want it to be 0. So now you've configured all the 4 interface of your ASA. If you just see, show run interface, okay, and see the configuration, you can see directly from here. So for example, you can check on which particular interface, what is the name if given, what is the security level, and what is the IP address with the mask. Though you have not configured the mask for those ports, thinking they are classful, but on the running configuration, you will see the mask, the default mask will appear for the ports. All right. And if you see show interface IP brief now, you can see that the port status and what is the IP address configured on the respective ports. And if you see show route, you can see the routing table that lists you all the connected routes. So 1011, as I've told you, that will not list the port number, but rather it will list the name of the interface. So you will see the keywords as C and L. So L is basically the host route, so or local route. It will tell you what is the IP address configured for that network locally on the port in the routing table as well. All right, so we have got 4 networks over here. So 1011, 192.120 going outside, 3.0 for DMZ3 and 4.0 for DMZ4 respectively. So you can see here that we have inside 100, outside 0, but DMZ3, 4 are kept as security level of 50. So by default, what happens is if I've got multiple interface with same security level, no traffic is allowed by default. No traffic can traverse from DMZ4 to DMZ3 or vice versa. Nothing is allowed by default because they have what? The same security level. Now, if you want to allow this traffic, let us see, if you want DMZ4 resources to talk to DMZ3 resources, there is a special command in case of ASA. The special command is called as same security traffic permit interface. So this is a very important command. If you want to, very important, but also very unrestricted command, okay, because it hampers security a little bit. The reason is when you give this command globally on the firewall, same security traffic permit interface, what happens is all traffic from the same security level will be allowed to traverse through the firewall from one zone to other zone. All the traffic is allowed. Now you need to be granular and allow only the respective traffic that you want and block rest of them. Okay, so that you can control using what? By writing ACL. All right. So now if I want to test the connectivity, how do I test the connectivity? From R1, if I want to test the connectivity with using pings. So answer me these things, guys. So now you know what we have done till now, right? We have configured the IPs, our routings are ready. We connected routes on the ASA, the initialization is done, and the basic IP addresses on the ports, the security level is configured. So now from inside router, let's say I'm trying to ping the ASA, which is 10.11.11.10. Will that work? ICMP is allowed as a 2 traffic. So I'm just sending a 2 traffic to the firewall port, and ICMP is there by default, so I can ping. The first packet will be dropped by default because of what? Why the first packet normally gets dropped? For the ARP resolution that is taking place. The rest, the pings will be successful. Right. So similarly, you can check the connectivity from the firewall as well to other routers, just to ensure that everybody is working fine. So from the ASA, if you try to ping, which is 192.1.20.2, if you want to ping 192.168.4.4, 192.168.3.3. So DMZ4 3 are pinging, and also 10.11.11.1, my inside is pinging fine. So two traffic is working fine. Only what? Pings. So from here, all the two traffic that I've sent across, they're working fine. It's all about ICMP. But what about the through traffic now? Right, through traffic. So if I go to R1, okay, from R1, if I try to ping R2's IP address, can I ping? So from R1, if I go to R1 console and if I say ping, which is 192.1.20.2, you think that will work? My ping works with ICMP, and by the way, ICMP has got multiple services, but two most important services are echo request and echo reply, right? So echo request will have a, so every ICMP headers, I mean, they go with one concept called as type and code value in the header. So echo request type is 8 and the code is 0. For echo reply, the type is 0 and the code is 0, right? So if I'm trying to ping from R1 to this guy, since I'm sending the traffic from high security to low security, and routing table, there is no concern because the firewall knows this network as connected route. So my ICMP echo request will travel from inside to outside. But what will not happen is the ICMP echo reply, when he will generate, the echo reply will come to the firewall. The echo reply packet will come to the firewall. But the firewall will say what? I don't have what? I don't have a connection table entry for you. I don't have a connection table. The first thing it checks, that do you have a connection table? The answer is no. If there is no connection table, then it will check what? ACL. Do you have an ACL for you to send ICMP reply packet from this IP address to this IP address? If there is no ACL entry, if there is no connection table, then it will check what? Security level. So security level says what? It is going from low to high. So it will be dropped. So which feature of your firewall is dropping the reply packet? The security level. How can you overcome that? By writing what? An explicit. In case of ASA, the ACL are generally called as the policies or firewall rules. When you think about rules, firewall policy, generally you control them by writing what? ACL. All right. So if you think like that, I mean, just notice and focus. I go to R1 and try to ping, which is 192.1.20.2. So first of all, I mean, this ping will not happen. The reason being, does R1 know regarding this destination network from its routing table point of view? Does R1 knows this network from routing table point of view? R1 knows what? Only connected routes. Everybody, as of now, it knows what? Only connected routes. So for R1, it knows 10, 11, this 10 networks in the routing table. Apart from that, any other networks, which is non-directly connected networks for R1, it is not known. Agree? So if I go to R1, if I try to ping this destination IP of 192, what will be failing? I mean, the router itself will not send the traffic because routing table entry does not have the destination IP in it. So if I look into the routing table right now, or if you do a, let us say, small debug, just for fun, debug IP packet details, okay, and if you type ping, which is that 192.1.20.2 outside IP, and see what is the debugs you get. What do you get here? You're generating the echo request, that is type 8 code 0. You're sending the traffic from 10.1.1.1 to the destination. You're generating that, not sending it, because it is unroutable from your routing table point of view. If you look show IP route, you see that regarding 192, there is no entry known. First of all, you need to solve this problem, right, of routing. So generally, let us say, generally what I'm doing is, I'll be running protocol later, but generally, I'm just saying that I have a static route to reach 192.168, 192.1.20.0, which is via 10.11.11.10 as my next hop. So I'm configuring a static route on R1 so that I reach this network 192 via 10.11.11.10. So now if I look, show IP route static, I have a static entry to reach that network, right? But what will happen next is again R2 to reply back to 1011 people, he will not have a route. So let's go to R2 and also configure a routing entry for that. So on R2, I say IP route 10.11.11.0, which is via 192.1.20.10. Okay. So now if you look for R2, show IP route static, you have this 1011 network known to it via the firewall. So now regarding routing, there is no concern. So 1011 know how to reach 192.120.0, and even R2 knows how to reach back to 1011 network. But in this case, if you try to ping from R1, you try to ping, which is 192.1.20.2, though the routing issue is solved, but still your replies won't come back. All right. You can see we're running a debug on R2 that he is getting the echo request. So debug IP ICMP if you do, you can see that R2 will be getting the echo request. Let's do it one more. You can see that R2, it is getting the echo request, and it is sending the echo reply as well to the destination of 10.11.11.1. But the problem is, the moment it reaches the firewall says, hey, listen, I don't have a connection table for you. Plus, I don't have what an explicit ACL defined to me to reach, from 192 to 10.11.11 network. Okay, so the security level is blocking it. So if you go to the ASA now, and if you see show con, or with this is the command to see the connection table, you see what? There is no table as of now that is present. On the other hand, if I go to R2, right, and enable R2 as a telnet server, let us say I enable telnet over here. So command is, I think you guys know that, line VTY 0 space 4. So I give a password for telnet. I say login. I say transport input all, and I configure a device password. All right, so I enable telnet on R2. So now from R1, can I telnet to 192.1.20.2? So the answer is yes. Telnet will work because telnet protocol, is based on TCP. So once you telnet, how the packet flow or packet structure will look like. So you'll have a data at layer 7. This is your telnet traffic, and this is telnet traffic will be actually encapsulated by TCP at layer 4. The source port number is a random, say it is 1095. Destination number is 23 for telnet as a port number. Then you will have the layer 3 header, where we will add the source IP, you will add the destination IP. Source IP is actually from R1, so it is 10.11.11.1. Destination IP is 192.1.20.2. Then you'll have the MAC address of yourself and the default gateway to send the traffic. Right? So the whole idea is when this traffic goes from R1 all the way to the firewall says, I have a routing table to reach this, and you are going from high security to low security. And since it is a TCP based traffic, so let me create a connection table also for you. So in the connection table, the firewall will actually have a reflexive entry. So whoever is the source will become destination, whoever is the destination, that becomes the source. So this was a source port number, this is your destination port number. So in the connection table, when you look for, it will have the source IP, it will have the source IP as 192.1.20.2, and the destination would be 10.11.11.1. Regarding the port numbers, the source port number should be 23, the destination port number should be 1095. So basically in the connection table, it is trying to allow the traffic from exactly from these guys, right? So when the telnet session gets established, I mean, you know that it is based on TCP three-way handshake. So since it is a TCP traffic, telnet will be established based on TCP three-way handshake. So basically when the SYN packet, so basically telnet is basically you are sending the TCP SYN packet over here. When the SYN packet is traveling from inside to the outside, this is the SYN packet will be allowed, and on the connection table, this entry will be there, because of which the SYNAC will come back. So you send SYN, and the SYNAC will come back from R2 towards R1 because of the connection table. And then when you send back ACK, it will go and the session will be established. So the whole idea is telnet will work fine, ensuring that it is TCP based traffic and connection table is maintained. So let's do a telnet over here, and you can see it is working great. Cisco, I can go to the device, I can see password, right? So I went to R2 from R1, and if I see here show users, I can see who has logged in, and I can see 10.11.11.1 has logged into R2. Let the session be there, and if I go to the firewall now, and if I see show con or show connection table, so I can see that there is a entry in the firewall regarding this connection table. So the connection table is allowing the traffic from outside, which is TCP based traffic. This is the source IP, this is the source port number, going to inside, this is the destination IP, this is the destination port number. All right, this is actually the connection table in use, and because of which, the return traffic is allowed to come back. So let's exit the session. And if I go to, let us say R1 now, so from at R1, let us say if I enable telnet, so line VTY 04, password Cisco, login, and transport input all, enable secret Cisco. If I enable telnet on R1, can anyone answer me this? If I go to R2, from R2, can I telnet or can I ping to 10.11.11.1? Can I ping from R2 to R1? The answer is no. The basic reason is what? Low security to high security. This ping will never work. If I want to allow it, what should I do? Write an ACL, correct. All right. So now can I telnet to this guy again? 10.11.11.1. Again, low to high. And here it is because the telnet session is getting initiated from outside, right? So this will not happen. So inside can telnet to outside, but outside can't telnet to inside. All right.